This video will present examples of point mass algebraic calculations of the center of mass. The point mass treatment of center of mass defines center of mass as the ratio of the vector sum of the mass-weighted position vector divided by the total mass of the point masses. Let's take a look at this with an example. Because this is a vector problem, draw a picture and declare a coordinate system. For center of mass problems, the two variables that are important are mass and position, keeping in mind that position is a vector, so keep track of plus and minus. Include the center of mass data as well. Declare the equation for center of mass, including all masses. Then algebraically solve for the unknown. Plug in with units and calculate the answer. Note that the units should come out in meters. Finally, check your solution with the picture you drew at the beginning that it is sensible. Your center of mass should not be outside the bounds of the system and should be weighed towards greater masses. Let's demonstrate on a second example. This time, the known includes the center of mass. The unknown is the position of a third mass to balance the first two. Once again, you start with the drawing. Again, create a list of the variables of masses and position vectors, including the center of mass. Declare the equation for center of mass, now for three masses, and algebraically solve for the unknown, keeping in mind that some variables might be zero, simplifying the equation. Plug in with units and calculate the answer. As before, check your solution with the picture you drew at the beginning. Remember, the center of mass must be inside the extremities. Consider weighing options. In this case, mass 1 and 2 weigh a lot more than mass 3. Hence, mass 3's position must be well outside the center of mass 1 and 2. Keep in mind that these steps and considerations can be generalized in more than one dimension, in which case you need to have a solution for each coordinate separately.